All right, so today we'll take a look at section 12.2, which begins on page 776, and this is polynomial division. And this is really the basis for essentially the rest of the chapter. So this is very, very important. So there are two different types of polynomial division. There's long polynomial division and there's synthetic division. So we're going to start with the long polynomial division. And so what we're going to do is we're going to take something like 2x squared minus 7x plus 8. And we're going to divide that by x minus 2. And so this is going to be long polynomial division first. So when we draw our division symbol, which one goes inside? The first one. So 2x squared minus 7x plus 8, and then this one goes on the outside. Now, this is extremely important. When you do your long division, before you start dividing, you've got to look at your two polynomials, the one inside, the one outside, and you have to see if any of the terms are missing. So make sure they're in standard form, meaning starting with the highest power of x and working your way down to the constant, and look to see if anything is missing. Is anything missing inside? No, we have x squared, x, and then the constant. But if there was no x there, then you would have to put a plus 0x to hold its place. If you do not use placeholders, you guys are asking for problems. Because then your like terms are not going to stay lined up with each other, and you're going to end up combining terms that are not like terms, thereby getting you the wrong answer. Now, in addition to looking at the inside, you must look at the outside as well. Is there anything missing on the outside? No, we have x to the first, and then we have our constant. Now, you don't have to go up to whatever this highest power was. You just have to look at it by itself and see if anything's missing as you go from the highest power down. So we have x to the first, and then x to the 0. We're good. So now we can start dividing. Now, before we go through the process of long polynomial division, let's refresh your memory on how regular long division works. So what do you do first here? I'm sorry? Yes, 27 into 63. Okay, so 27 doesn't go into 6, so we check to see how many times 27 goes into 63, which is how many? 2. So you put a 2 up here, now what do? Yeah, you take the number you just wrote on top, multiplied by the whole thing that you have in the front. Do we do just the 2 times the 2 or the 2 times the 7? No, it's 2 times the whole thing in front. 2 times 27 is 54, you write it here. Now what? Subtract. Now, for purposes of today, guys, I don't want you to think in terms of subtracting. Another way to think of subtraction is to add the opposite, right? So what we're going to do is we're going to change the sign on this bottom row, and then we're going to add them together. That's the same thing as subtracting, right? And you'll see why we do that in just a minute. So 63 minus 54 is what? Then you bring down the next number. And now you do the process again. How many times is 27 going to 99? 3, which gives us almost 81. Now, again, we're going to subtract, which means change the signs and add, which leaves us with what? 18. And so this becomes, well, the first way you learned how to do division was to put remainder 18 up here. And then after that, you guys learned how to write the remainder using a fraction, which was to write it as 18 over 27. Now, that actually reduces to what? 2/3, right? So you would then write 23 and 2/3. Okay? But you first learned how to write it using the r, then you learned how to do it just putting this number over that number, and then you talked about reducing it. That's basic long division. We're going to do the same thing here. So the question is, you look at this term and this term. How many times does x go into 2x squared? And another way of asking that is, what do we multiply x by to make it 2x squared? 2x. So we're going to write a 2x up here. Now you can write the 2x here, or since there's two terms, you can write the 2x here. It really doesn't matter, because we're not going to have to worry about decimals and things like that anyway. It's really only important if you're putting decimal points in long division. Now what do? Multiply 2x times the whole thing out in front, which means this has to distribute, which gives us 2x squared minus 4x. Everybody with me on that? What's the next step? Subtract, which means I told you we're going to change the signs and add. So the problem, guys, is if you just write a minus here, people will remember to do 2x squared minus 2x squared just fine. What will they mess up on, though? The negative 7x minus 4x instead of doing negative 7x minus negative 4x. So to avoid that, we change the signs on the bottom row and we add the two rows together. And then you're distributing the negative so you don't have to worry about doing it separately. Now, these cancel out. What are we left with? Negative 3x. And now we bring down the next number and we do the process again. How many times does x go into negative 3x? Negative 3 times. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Subtract, which means change the signs and add. Those cancel. What are we left with? 2. And so we're not going to write R2. We're going to write plus 2 over x minus 2. So this is one way of writing this answer. Questions about that? The remainder is 2 over what we divided by, just like the 18 over 27 here. So your remainder divided by your divisor. Not in this particular form. Now, there is another form that they can ask you to write the answer in. And that is that they can ask you to write the answer in this form. P of x equals d of x times q of x plus r of x. Meaning this is some polynomial in terms of x. This is your divisor in terms of x, or as a function of x, your quotient as a function of x, and your remainder as a function of x. So what are all these things up here? Well, this is your p of x. That's your original polynomial. This is your d of x. That's your divisor. What you're dividing by. Okay? Your quotient is this part. And your remainder is this part. Not written as a fraction. It's just the remainder, however, comes out on the division. So another way of writing this is that p of x, 2x squared minus 7x plus 8, is equal to d of x, which is x minus 2, times q of x, which is 2x minus 3, plus r of x, which is 2. Notice if you FOIL this out, you get 2x squared. You get minus 3 minus 4 is minus 7x plus 6. And then when you add the 2 to it, you get the plus 8. And so the two sides will match. So a lot of times, this is what they're going to want from you guys. They're going to want the p of x equals d of x times q of x plus r of x. So you have to read the directions and see what they want. Now, this form is very important to what we're going to do tomorrow when we start talking about the remainder theorem, the factor and remainder theorems. Okay. Any questions about this process? Okay, let's do one more of these. Let's do one where we have some stuff missing. So now what we're going to do is we're going to do 3x to the 4th minus 2x cubed plus 2 divided by x squared minus 1. Okay? And so when we write our division symbol, which one goes inside? The first one. 3x to the fourth minus 2x cubed plus 2, and then the other one goes on the outside. Now, the problem is, guys, if you start your division, you're going to get all messed up, because you're not going to have all your x to the fourths and x cubes and x squareds and everything lined up. Notice here, the x squareds and the x's and the constants all lined up perfectly in the division. That's because we made sure that every place was represented. We have to do the same thing here. We're asking for trouble. What's missing here? X squared and x, which means I need to put a plus 0x squared and a plus 0x in, and then I can write my plus 2. Now, if the constant was missing, you still put a plus 0 for the constant. Anything that's missing as you work your way down from the highest or the leading term has to be represented by a placeholder. Is anything missing on the outside? Yeah, what's missing on the outside? X. So what we need to do is we need to make this x squared plus 0x minus 1. Now, watch as we do our division. You will see that all of our powers of x line up with each other perfectly, so we don't have any issues when we go to combine like terms. So, x squared goes into 3x to the fourth, 3x squared times, which gives us 3x to the fourth plus 0x to the third minus 3x squared. Now what? Yeah, change the signs and add. Change, 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 add them up. These cancel. This is negative 2x to the third plus 3x squared. Now you bring down 0x. Now, one thing about bringing down the next term, guys, notice how many terms are on the outside here? 3. You need to have 3 terms on the inside also for the piece that you're dividing into. If for some reason these canceled out and these canceled out, I would have 3x squared plus 0x. This would not match the same number of terms that we're dividing by. Do you guys see that? So unlike regular long division, if you need to bring down the next 2 terms at the same time to continue your division, you can do that. So if this was not here, then I would have brought down the plus 2 also. Everybody got that? So that I would have the same number of terms here as I have out here. We didn't have that problem, but if you do have that problem, that's how you deal with it. Okay, so x squared goes into negative 2x cubed, negative 2x times. That's negative 2x cubed plus 0x squared plus 2x. We're now going to change the signs and add. Those cancel, and we have 3x squared minus 2x. We bring down the plus 2. And now x squared goes into 3x squared plus 3 times, which is 3x squared plus 0x minus 3. We change the signs and add. Those cancel, and we end up with negative 2x plus 5. And so if I'm writing this in the p of x equals form, it would be 3x to the fourth minus 2x cubed plus 2. I don't need the placeholders anymore. Equals p of x, so I divided by x squared minus 1. Again, I don't need the placeholders. I'm done dividing. Times the quotient, which is 3x squared minus 2x plus 3, plus the remainder, which is negative 2x plus 5. So again, this is your p of x equals d, let's fix that, d of x times q of x plus r of x. Now, if they don't ask for that form, then you would have written it as 3x squared minus 2x plus 3 plus negative 2x plus 5 over x squared minus 1. Again, we don't need the placeholders anymore. Now notice, guys, there was a minus here. Could I have just written minus 2x plus 5 over x squared minus 1? No, because then that negative would have to distribute and would change the sign on the 5. So if I wrote it that way, I would have to write it as minus and then 2x minus 5 over x squared minus 1. To me, you're just asking to make a careless mistake when you do that. So don't do that, guys. Always write it with a plus, and then whatever this is divided by whatever this is without the placeholders. And then you're good. So remember, though, to read the directions and see which form they want you to write the answer in. Whether they want it this way or whether they want it this way. Questions? Okay. Now, the next thing we need to talk about is synthetic division. So what I want to do is I want to take this for a minute. That wasn't what I meant to do. Let's try that again. Helps if I hit the right button. Let's go to a new page. There we go. There was our long division, right? Now what we're going to do is we're going to talk about synthetic division. So again, we're doing the same 2x squared minus 7x plus 8 divided by x minus 2. To set up your synthetic division, what you do is you start by peeling the coefficients off of your polynomial, your p of x. So we have 2x squared, we have negative 7x, we have 8. Is anything missing? No. That's why we didn't need any placeholders. If something is missing, guess what you have to fill in here? A 0. Guess what happens if you don't fill in the 0? Yeah, you get the wrong answer pretty much 100% of the time. Okay? So you need to make sure that you guys fill in any missing zeros. Now, what you then do is you draw to the left of your first number, your first coefficient, or I should say your leading coefficient. You draw a little box like that, a little platform. Then you skip a line, and then you draw a line. You skip a line because we're going to write some more numbers on this bottom row. Then you bring the first number straight down. This is the beginning setup for every synthetic division problem you ever do. Any questions about that? Now, a number needs to go on this little box to finish setting it up so that we can divide. And what goes on the box is you take whatever this divisor is and you set it equal to 0 and solve for x. That's what goes on the box. That's the root of the equation that we get from that divisor. If it is, in fact, an actual root of an equation. Now, we're not actually doing any equation solving here. We're actually just doing division. But this will end up being the root when we start actually dividing. When we start actually solving, excuse me. So that is the value that goes on the box. Now we're done with the setup. Now we start dividing. And in order to do the synthetic division, what we do is we take the number on the box, on the platform, times the last number we wrote on the bottom. What's 2 times 2? 4. And you write it here in the next column. And then you add. You do not subtract. You add them together. No changing signs in adding. It's just plain old adding. Negative 7 plus 4 is what? Negative 3. Now you repeat the process. What is 2 times negative 3? Negative 6. Then you add those together, which gives us 2. We're now done, guys. We just accomplished the same thing here that we accomplished here. So what it is our answer is the following. This was 2x to the third. This was negative 7, I'm sorry, x squared, excuse me. 2x squared, this was x to the minus 7x to the first, and this was our constant. But we're dividing by something with an x in it. What happens when you take an x squared and you divide by an x? You're left with an x. What happens when you take an x and divide by an x? You're left with a constant. Right? X to the 0 power. What happens when you take a constant and you divide by x? What do you think you get? Remainder. So everything drops by 1 degree. X squared becomes x. X becomes the constant. Constant becomes the remainder. Everything drops 1 level. And so that means our answer is 2x minus 3 with a remainder of 2 over what we divided by. Do you guys see that this matches this? Now, this was a very simple, straightforward problem. Was one considerably easier than the other? Yeah, actually, even on this simple problem, isn't the synthetic way a lot easier? Now imagine, guys, if instead of x squared, this was x to the 12th power. And a bunch of stuff on down. Can you guys imagine this was like x to the 3rd or something? Can you guys see how long this problem would be? And how much paper and room and how many steps it would take? And all the distributing and subtracting and changing signs? But if the same problem was done here, it would still just be 3 rows. It would just be going farther this way, but all you're doing is multiplying and adding, multiplying and adding, multiplying and adding, you're done. So do you guys see that the longer the problem is, the nicer synthetic division becomes? It saves you a lot of time and a lot of potential for careless mistakes. Yes, sir. What do you mean it will always be one term? Oh, I'll talk about that in a minute. Hang on to that question. Okay, any questions about that process? And so again, this could be written as 2x squared minus 7x plus 8 is equal to the divisor times the quotient plus the remainder. We're not changing the way we can write the answer, we're just changing how we get to the answer. How we write it depends on how the question is asked. Questions about that? Now, the benefits of synthetic division are tremendous, but there is a drawback. If there wasn't a drawback, there'd be no need for me to show you long polynomial division. The drawback to synthetic division is that on synthetic division, your divisor must be linear. In other words, this guy right here must be linear, meaning what? Yeah, only to the first power. Your variable can only be raised to the first power. So, synthetic division saves us lots of time here. What about this problem here? Sorry, wrong one. What about this problem here? You can't do synthetic division, and the reason you can't do synthetic division with anything other than a linear divisor, guys, is where did the number on the platform come from in synthetic division? Comes from the roots of this guy equal to 0. Well, when I saw this guy equal to 0, what do I get? Plus or minus 1. How can I put two numbers on that platform and use this process at the same time? But that's two separate synthetic divisions, not one synthetic division. So you have to use 1 first, so then we're not dividing by x squared minus 1, we're only dividing by x plus 1 or x minus 1. Which you could do. There's also a way to do double synthetic division, but you guys will mess it up if you try and set it up that way. It's a little bit of a trick, where you're just doing 2 at one time. But you can't do one synthetic division using 2 different roots. It's not possible. Only one number can go on that box at a time. Any questions about those? Now remember, guys, that if you are missing things, so for example, if you're doing 5x to the 5th minus 8x cubed plus 2x squared minus 7 divided by x plus 1, this is what your synthetic division needs to look like. We have 5x to the 5th, we have 0x to the 4th, so we have to put the placeholder in. Negative 8x cubed, 2x squared, 0x minus 7, and on the platform we get a negative 1, because when I set this equal to 0, I get x equals negative 1. Bring the first number down, and now you start your process. Everybody with me so far? Negative 5, which gives you negative 5. Positive 5, sorry, let me get this going again. So that gives us positive 5, negative 5 times negative 1 gives us negative 3. Negative 3 times negative 1 is 3, that's 5. 5 times negative 1 is negative 5, that's negative 5. Negative 5 times negative 1 is 5, that's negative 2. So this was x to the 5th, so what is this going to start at? X to the 4th. So our answer is going to be 5x to the 4th minus 5x cubed minus 3x squared plus 5x minus 5 plus negative 2 over x plus 1. Or it could be written this way, right? If they asked you for the PDQR version. It would be, 5x to the 4th, no, sorry, we have to start with the divisor, x plus 1 times the quotient 5x to the 4th minus 5x cubed minus 3x squared plus 5x minus 5 plus the remainder, which is negative 2. Any questions about our division? Now, what we're eventually going to be interested in, guys, is related to this form. What's going to happen when we learn the factor and remainder theorem is this. Specifically the the factor theorem. What happens if this number here ends up being a 0? Then this ends up being a 0. So this is a what if. If this ends up being a 0, does it need to be there? So if the remainder ends up being a 0, this is what we get. We get that our polynomial is equal to our divisor times a quotient. What did we now just do to this polynomial? We factored it. Do you guys see that? That if the remainder upon division is 0, that means this goes into this evenly this many times, which means we have now factored this. And so what we're going to do in this chapter is we're going to use synthetic and long division as a tool to help us factor something that otherwise we would be unable to factor, so that we can continue to break it down and solve it. Because which of our factoring shapes does this fit? Grouping, but if you group this, you could factor out an x cubed, but that leaves you 5x squared minus 8. There's no way to get a 5x squared minus 8 by factoring something out of that. It doesn't matter how you group it. You could group the first and third and the second and fourth, or the first and last and the middle two. You're not going to be able to factor this by grouping. It won't fit any of our other factoring shapes. Trying to solve this, you'd be out of luck. You can't use the quadratic formula on it. Why not? It's not that it's more than 3 terms. I could take off the minus 7. It would be 3 terms. Well, we don't. Yeah, you need A, B, and C, but specifically, what are A, B, and C? Now you're getting close to what I'm talking about. Yeah, the degree is too high. It's not quadratic. It's not x squared. It has nothing to do with the number of terms specifically. The reason we don't have the right number of terms happens to really be related to the fact that we don't have x squared as the highest power. This is not a degree 2 quadratic equation or a quadratic polynomial. This is a quintic polynomial, x to the 5th power. You can't use the quadratic formula on something that's not quadratic. And there is no quintic formula. There's only a quadratic formula. So that's why this method or this process is so important, is because it's going to allow us to solve things that otherwise we would have no tools for solving. All right, questions? All right, and in that case, the homework assignment. And again, this is not any different than what you did last year in Algebra 2. It's exactly the same stuff. So page 781, 782, you guys are going to do 1 through 39 odd.